Hello everybody and welcome to a new video. Today we're going to talk about something super interesting. So here I have a UV filter that comes in front of the lens, and probably a lot of you are using UV filters for protection of the front element of your lens. And luckily this isn't another generic video on this stale topic whether you should use a UV filter, yes or no. The one side says that you should use it for protection, the other side says they don't want the loss in quality. But luckily this isn't another generic video on that topic. Today we're going to talk about why UV filters are technically useless and how UV light actually affects digital cameras. But to understand how UV light affects our modern day cameras, we first need to understand how light works. Visible light basically is just a bunch of photons which move through space as a wave. They have different wavelengths and thus different energy levels. A shorter wavelength means the photon has more energy. This is the visible spectrum. It incorporates the wavelengths of light which humans can see with their eyeballs. Each wavelength corresponds to a color. For example, 460 nanometers is a blue tone. The visible spectrum reaches from about 380 nanometers, which is violet, to 740 nanometers, which is red. If we go further to the right on this scale, we have infrared light, which isn't visible to the human eye. If we go further to the left from violet, we have higher energy photons in the ultraviolet range. Because ultraviolet rays are higher energy, they can also cause disruptions in the cell cycle and thus cause skin cancer when a person is exposed to them for long periods of time. So humans can see ultraviolet light or infrared light, but camera sensors actually can. Here is an image taken completely with infrared light. But we don't want our images to incorporate infrared light or ultraviolet light. We want to freeze the moment and have it look the way we saw it with our eyes. That's why consumer cameras actually have a filter in front of the camera sensor that blocks all infrared light. Some enthusiasts remove this filter. It's especially useful for astrophotography because many objects in space emit infrared light. But what about UV light? Don't we have to block that too? This is where my knowledge on the topic ended. Everywhere on the internet, people were just talking about the low pass filter in front of the sensor, which blocks infrared light. But shouldn't we also block UV light in front of the sensor? And wouldn't that render screw-on UV filters useless? I took to Stack Exchange to find an answer. The answers I received weren't very good, to be honest. They were all saying something different. I was a bit confused, but they nudged my research in the right direction. It turns out that there were two pieces of information I was missing. The first one is the color filter array, or CFA for short, sometimes also called color filter mosaic. Sensors consist of a bunch of photosites, basically pixels. These take the amount of photons that hit them and convert them into an electronic signal. Photosites typically only detect light intensity and have little to no wavelength specificity. Therefore, there has to be something to determine the actual color that is hitting the sensor and not just the light intensity. The most commonly used color filter array is the Bayer array. This Bayer array sits in front of the photosites. Each submosaic is 2x2 filters and consists of 2 green, 1 blue and 1 red filter. Each of these filters cover 1 pixel. The filters only let through their respective wavelengths. A green filter would therefore only let photons pass to the photosite, which have a wavelength in the green spectrum. This process results in an image built out of RGB values. But there is another important factor to take into consideration. When you're looking to buy a camera online, you've most likely read the term, "This camera has an X megapixel CMOS sensor." CMOS actually stands for complementary metal oxide semiconductor. It's the sensor technology that pretty much all consumer cameras use. Each photosite is one of these semiconductors. It turns out that these semiconductors aren't very sensitive to UV light. To understand how strongly CMOS sensors are affected by UV light, we first have to take a quick look at quantum efficiency. This term sounds like straight out of science fiction. You can work it into any conversation and anyone who doesn't know what it means will instantly think you are building a time machine in your garage. But it's quite simple despite the intimidating term. Remember what I told you earlier? A photosite takes photons and converts them into an electric charge. Quantum efficiency just shows how efficiently this is done at different wavelengths. It is usually measured in signal electrons per incident photon, so how much electrical energy we get from a specific photon hitting the photosite. This is a graph showing the quantum efficiency for different wavelengths of a CMOS sensor. You can see the wavelength on the x-axis and the efficiency on the y-axis. The The interesting thing about this sensor is that it was built specifically for being highly UV sensitive. But when we look at the near UV and UV spectrum, you can see that the quantum efficiency isn't very high compared to the visible spectrum. So even a sensor that was built for being highly UV sensitive isn't that sensitive to UV light. And the color filter array also only lets through red, green or blue. Why do UV filters exist then? In the analog era, UV light could cause tinting of the film, so having a UV filter in front of your lens was very important. But in the digital era, UV filters are pretty much useless. I've heard reports online stating that the difference can be seen in high altitude areas between UV filter and no UV filter. But I haven't tested that out personally and I haven't found any example photos of that online. So in the end, the UV filter is nothing more than a method for protecting your lens, and I'm definitely keeping my UV filters on my expensive lenses to protect that front element. Or it could also be a method for the camera shop's salesman to squeeze another $50 out of your bank account, whichever way you look at it. So I hope you enjoyed this video and learned something. A lot of research went into making this video. If you are interested in reading about this, I basically have the same content as this video in a text form as an article on my blog, and the link is in the description. So if you want to come back to information or want to read over it once again, I don't know, you can check that out in the description. Also, it would be really nice if you can check out my Instagram account. I have two. I have FUTC.photography for photography and FUTC.coding for computer science related stuff. So if you don't want to miss any new videos, then you can subscribe, and you can also hit that notification bell to get notified when I upload again. Also, you can leave a like, that would help me tremendously, and you can join the discussion in the comments. And yeah, that's about it. See you in the next video. Bye bye.